Hello everyone, welcome to this video presentation of Cloud and Beyond. Today I'll be covering 5 key points from the week 2 cloud service model and the cloud deployment models, security issues in SaaS, yes, AAS, authentication and authorization in SaaS, a security issue in a IaaS, and let's get started. Let's talk about the cloud service model. Cloud computing is delivered through 3 core services model, each offering a different level of control and responsibility to a customer. First, let's talk about the SaaS, which is also known as software as a service. In a SaaS model, the host applications that consumer access over the internet through a web browser or a program interface. The consumer has no control over the underlying infrastructure, no management of the server, storage network, or the operating system. They can only configure the limited application level software or the settings. Example including a Google Map, Google Apps, Salesforce, and Dropbox, and even a Spotify. No, not Spotify. I mean the Shopify. Think of a SaaS as a renting a fully furnished apartment. You use everything, but you own nothing. And let's talk about the PaaS, which is also stand for the platform as a service. PaaS gives a consumer a platform to deploy and run their own application built using a languages, library, tools, and supported by a provider. The consumer doesn't manage the underlying the hosting environment settings. Example including the AWS Elastic Beanstalk, Google App Engine, and Windows Azure. PaaS is a renting a kitchen. You bring your own recipes and cook it, but you don't manage the building. Let's talk about the IaaS, which is also known as the infrastructure as a service. IaaS provides the most control consumer can provision, process power, storage, and networking resources and run any software, including operating systems and applications. They don't manage the physical hardware but do control the operating system, software, and deploy the apps. Example including Amazon Web Services, which is also known as the AWS, Microsoft Azure, Cisco Metapod. IaaS is like leasing a plot of a land where you build and manage everything on it. Um, Specialized variations are beyond this. The three many specialized model exist, including a storage as a service, security as a service, and database as a service, and more. Each built as a distinct combinations of the IT resources. Combined models are these 3 models can also be layered. For example, a PaaS environment is built on a top of IaaS infrastructure, and a company can use IaaS plus PaaS together to develop and deploy its own SaaS product to end users, creating a full tier cloud architecture. So now let's talk about the cloud deployments model. Cloud infrastructure can be deployed in a four main ways depending on how you use it and who controls it. Public cloud. The cloud infrastructure is available for open use by the general public. It may be owned and operated by businesses, academic institutions, or government bodies, and it is physically exists on the cloud provider premises. This is most widely used model. Think AWS and Google Cloud. Private cloud. This cloud is set up for exclusive use of a single organization to make a secure. Through it, many server, multiple internal department. It can be managed by organization itself or a third party. You can exist on or off the organization premises. It offers a greater control and security by a higher cost. The third is hybrid cloud. A hybrid cloud is a combination of a two or more distinct cloud environments, private, community, or a public. The remaining separate, but that remain separate, but are linked through the standardized technology. This allows data and application portability. For example, using a cloud bursting to shift our workloads to a public cloud when a private cloud reaches capacity. Community cloud. This model serves a specific community or organization with a shared conscience, such as shared security requirements, compliance, obligations, or a common mission. It can be owned by one or more community members or a third party and may exist on our off premises. As an example, would be a group of hospitals sharing a HIPAA compliant cloud. Now, let's talk about the security issues in SaaS, which is also known as security issues in software as a service. Cloud architecture introduces significant security challenges, and it in the SaaS model, the client is entirely dependent on a provider for a security. The customer cannot even verify that the right security measures are in place. There are 7 key security elements to consider in a SaaS. The first one is data security in a SaaS. In a SaaS enterprise, data is stored outside the enterprise boundary. As a vendor infrastructure, the vendor must implement a strong security check to prevent breaches caused by an application vulnerabilities or malicious insider. Unauthorized access to weaknesses in a data security model is a real and serious risk. Second, network security. All data flowing over the network must be encrypted to prevent encryption or sensitive information. Common techniques including SSL and TSL. Without this, malicious user can perform a packet sniffing attack, capturing a data as it travels across the network. Third is data locality. SaaS consumer often don't know where their data is physically stored. This is major compliance concern many countries, particularly in Europe and South America. So they have a law preventing a sensitive data from leaving a national borders. A secure SaaS platform must be able to guarantee the geographic location of a data store and clearly jurisdictional responsibility during a legal investigation. The fourth one is data integrity. Data integrity ensures that the data is accurate, consistent, and unaltered. Its standalone system. This is achieved through the through ACID properties, which stands for atomicity, consistency, isolation, and durability, which enforces by a database transactions. In a cloud environment, bypassing application logic to access database directly can break these integrity controls, leading to a serious data corruption risks. The fifth is data segregation. Cloud computing is inherently multi-tenant. Multiple organizations' data resides on shared infrastructure. This creates a risk that one user data could be accessed or viewed by another. Let's talk about the sixth, data accesses. Access control must reflect each organization's internal security policies. For example, an employee at a client company should only be accessed data relevant to their role. When an employee leaves, their account must be promptly disabled. When a new staff joins, an account must be created. In a multiple SaaS environment, this creates increased IT management overhead. One solution is for the SaaS provider to delegate the authentication to the client own internal server, so organizations retain user management control. So let's talk about the authentications and authorization issues in SaaS. Because SaaS applications are web-based, they inherit many of the same security vulnerabilities as a web application. Authentication is a process of verifying a user identity, confirms that users are who they claim to be. It is the first and most critical step in any security system. A weak or absent authentication mechanism can allow an unauthorized user to gain access to a sensitive data and services. In SaaS environment, these issues are compounded because the consumer has no control over the underlying application infrastructure. Security settings are largely managed by a vendor. Poor implementation of a session management or token handling can create exploitable vulnerabilities. Now let's talk about the security issues in IaaS. IaaS gives a consumer the most control of any cloud model, but it also brings a unique security responsibility. Better control, but not with the risks. In IaaS, the developer has a better control over the security as long as there is no security loophole in a virtualization manager. Virtual machines offer logical isolation, but in a practice, they are still significantly security vulnerabilities. The key IaaS security concerns are impact of a deployment model, physical security of a disaster management IaaS infrastructure, data transmission security in a cloud environment, and isolation from a public internet, which basically means IaaS environment exposed to internet are vulnerable to the cyber criminals and external attackers. Measures must be put in place to make the cloud environment private, isolated, and protected through a firewalls, a VPN, or an intrusion detection system or intrusion prevention system. To summarize, cloud computing is delivered through a three-service model that are SaaS, PaaS, and IaaS, which is also known as a software as a service, platform as a service, and infrastructure as a service, and deployed through a four models that are public, private, hybrid, and community. Each model carries its own security implication. SaaS require a vigilance around data security, integrity, segregation, and locality access, and especially authentication and authorization. IaaS, while offering a greater control, demands careful management of a virtualization, physical security, and data transmission. Understanding these risks is essential for any cloud architect or a security professional. Thank you for watching, and we'll meet in next week on week 3. Thank you.